Recently, Intel has launched Neuromorphic Chip Hala, which can process information like the human brain. This chip can process information 50 times faster than a normal computing chip. At the same time, it consumes less power than a normal chip. So today, we will see in this video what is neuromorphic computing and how can it revolutionize computing. What is a neuromorphic computing? Digital logic is used to make the computer chips used today, in which we use logic gate to make circuit, in which information is processed in the form of 0 or 1. But a neuromorphic chip can process signals like the human brain. Like our brain thinks something, so electrical signals are produced in neuron, which sends information from one neuron to another through synapses. Similarly, in a neuromorphic chip, we use artificial neurons and synapses, which are connected to each other when a spike is produced in a neuron. So it transfers to another neuron, and like this output spikes becomes input for another neuron, with the help of which it processes the information. The concept of neuromorphic computing was first published by Warren McCallum and Walter Pitts in their paper, A Logical Calculus of Ideas Immanent in Nervous Activity. Later in 1957, neural network perception was developed, which could learn simple tasks until 1980. Many researchers tried to understand how the brain cognitive processes work and how we can replicate with the help of artificial neuron. In 1986, Geoffrey Hinton, David Rumelhart, and Ronald Williams discovered the back propagation algorithm, with the help of which we can train a multi-layered neural network. The first project, whose aim was to create a neuromorphic chip, was initiated by Steve Furber in 2005. The name of the project was Spinnaker. The first functional neuromorphic chip, True North, was launched by IBM in 2014, which had 1 million neurons and 256 million synapses. Later in 2017, Intel launched its Loihi chip. But how is a neuromorphic chip made? First of all, we design the architecture and circuitry of the chip, in which neuron and synapses are designed with the help of electronic design automation software. Now we prepare this wafer, on which layers of silicon dioxide, silicon nitride and other metals are formed. After this, a photoresist layer is coated, after which we print the chip design on the wafer with the help of UV light. Etching is done after installing the electrical component on the chip, which removes excess material. After this, we dope the silicon wafer with boron or phosphorus, which increases its conductivity. Now we implant ions to change the conductivity of some regions. After all this process, we do annealing of the wafer, in which we heat the wafer first, then it is left to cool, which activates the dopant and improves the crystal lattice. After all this process, we coat the copper or aluminium to form interconnection between neurons. How does a neuromorphic chip work? A neuromorphic chip contains many artificial neurons, which receives the input signal, we process it and produce the output signal. Now, synapses transfer these output spikes to another neuron. As these spikes learn new information, the connection between two neurons called synapses changes. Similarly, in a neuromorphic chip, many neurons process information at the same time. But why do scientists want to develop neuromorphic computing? Efficiency. Every component of the chip works in a normal computer, due to which it consumes high power. But in neuromorphic computing, some neurons of the chip work in an event, which consumes less power. Real-time processing. Due to the low latency of the neuromorphic computing, we can use it for real-time processing. A neuromorphic computing responds quickly to any stimulus. Parallelism. A normal computer performs any task in sequence, because of which it is able to do only one work at a time. But a neuromorphic computer can do multiple works simultaneously, because it contains many neurons which can do many tasks simultaneously, which will help us in solving complex problems. Adaptability. Neuromorphic chip learns itself from new information, which can help us in many automation like robots. Not only this, if any neuron gets damaged, even then other neurons will continue to work without any interruption. Consciousness. We have taken inspiration from the human brain to develop neuromorphic chip. So neuromorphic chip can develop human-like perception in future, in which there will be human-like decision-making ability. But developing a neuromorphic chip like human brain is a challenge. Neural network scaling. Till now we have been able to develop only millions of neurons and synapses connections. But a human brain has trillions of synapses, which is a challenge to replicate. Learning algorithm. Currently used learning algorithm can change the connections between basic synapses, but now we have to develop such a learning algorithm which can completely use the hardware of the neuromorphic chip, integration with a normal computer. We cannot currently use a neuromorphic chip in a normal computer. For this, we will have to develop new hardware which can run it. But if we can solve these challenges, so we will have a powerful computer like the human brain, which will solve the complex problem in a few seconds. Support our mission of spreading scientific knowledge to everyone by sharing this video, like the video and subscribe to this channel. So see you in the next video. Bye bye.